All right, now we've showed you how truth values are verified or determined in statements. And then there are also immediate inferences that can be made. Okay, immediate inferences. Let's put up the square of opposition again for a moment. Here's A, E, I, O. All S is P. No S is P. Some S is P. Some S is not P. All right. Now let's show some immediate inferences. These are inferences that can be made with statements. So when a statement is made a certain way, there are two immediate inferences that can be made from every one of these statements. So we'll start with the A statement. All S is P. All beagles are dogs. Okay? An immediate inference is a statement that means the same thing as its original statement. Okay? So, we can, first of all beagles are dogs means, number one, no beagles are non-dogs. And number two, that all non-dogs are non-beagles. I'm going to have to show you how that is true from this. All right? So let's just do the relationships, or the immediate inferences. The first one is converse. We can use converse on the E statement and the I statement. Okay? E and I. E, no S is P, is logically equivalent to no P is S. Okay? No dogs or cats is logically equivalent to no cats are dogs. Then the I statement, some S is P, is logically equivalent to some P is S. So here we have some dogs are beagles is logically equivalent to some beagles are dogs. Now again, your temptation is to say, well, the second statement isn't true because you're thinking that some dogs are some beagles are dogs implies that some beagles are not dogs. But again, there's no logical implication between the I statement and the O statement. All right? Some dogs are beagles implies logically that some beagles are dogs. That's converse. The next set of immediate inferences that we can make is obverse. And obverse applies to all four statement types. The A statement, all S is P. Okay? With the obverse, we change the quality of the statement. So if it's affirmative, it becomes negative. This is an affirmative, so it becomes negative. So I'm saying that all S is P is logically equivalent to no S is, but there's one more thing I have to do. So I change the quality of the statement and I change the predicate to its complement. So this P, this predicate here, is changed to its complement, which means it's changed to non-P. All S is P becomes no S is non-P. This line over the top of the P means non-P. Have I lost you yet? Try to keep your eggs from scrambling. All S is P, okay? So, all people are human is logically equivalent to saying no people are non-human. Let's see. All squares are rectangles is logically equivalent to saying no squares are non-rectangles. The E statement, no S is P. Remember, we changed the quality of the statement, so the no becomes an all. All S is, and then the predicate is changed to its complement. All S is non-P. So, no cats are dogs is logically equivalent to saying all cats are non-dogs. All cats are non-dogs. Let's see. No hot dogs are apple pies is the same thing as saying all hot dogs are non-apple pies. Okay? That's obverse. The I statement, sum S is P. On this one, the sum doesn't change. The quality of the statement is what changes. So some becomes some not. Some S is not. And then again, we change the predicate to its complement. Some S is not non-P. So, you'll hear it on this one. It's actually, just listen to it. Some dogs are Rottweilers is logically equivalent to saying some dogs are not non-Rottweilers. That's where it gets confusing for you. But if you think about it, that double negative, not non, makes it a positive, just like they teach you in English class. All right, so some people are humans would be logically equivalent to saying some people are not non-humans. Okay? And then the O statement, some S is not P, is logically equivalent to some S is non-P. That's the easiest one of all. Some apples are not oranges would be logically equivalent to saying some apples are non-oranges. That's obverse. All right, the next one, there are three immediate inferences. The third immediate inference is called contrapositive. Contrapositive, now take a look. Obverse covers all four of the statement types. Converse covers E and I. Only E and I can switch the S and P. And here's why. Because the universal negative here it refers to every member of the S and every member of the P. No S is P. Not any of S is any of P. This refers to some S's and some P's. All right, so some S is P. There's a cross there. If I were to draw it as a Venn diagram for you, here's S, here's P. Some S is P. So the S that exists is in some of P. It's not in all of P. All right? So because the S and P are the same weight in the E statement and in the I statement, you can switch them. But in the A statement and the O statement, you cannot. You can't just switch. So, for instance, all S is P. Now, sometimes it sounds like it works. For instance, all people are human. All humans are people. That sounds right. But that's not an immediate inference that you can make. All fathers are men is not logically equivalent to all men are fathers. All mothers are women is not logically equivalent to all women are mothers. So it works sometimes, but sometimes it doesn't. And because it doesn't work sometimes, it doesn't work anytime. We can't make it work on that. So we have contrapositive. Contrapositive works on the A and the O. Let me show you how contrapositive works. All S is P is logically equivalent to, now here's what we do with contrapositive. We switch the subject and the predicate, just like what we did here with converse. But we have to change both of them to their complement. So all non-P is non-S. All non-P is non-S. So, all people are human would be all non-humans are non-people. On the O statement, some S is not P would be logically equivalent to some non-P is not non-S. Okay, so let me think here. Some dogs are not, some dogs, I'm trying to think of a different breed. Some dogs are not German Shepherds. Okay? Some non-German Shepherds are not non-dogs. Whew! That's a heavy one. But they are logically equivalent. Now, here's what you need to understand. For each of these statements, A, E, I, and O, there are two immediate inferences that can be made. For the A statement, all S is P. No S is non-P. And all non-P is non-S. Okay? So for the A statement, you have one obverse and one contrapositive, or C+, as I like to call it. Some S is P. You can use converse. Some P is S. And obverse. Some S is not non-P. No S is P. You have no P is S. That's converse. And you have obverse. All S is non-P. And then on the O statement, some S is not P. Some obverse. Some S is non-P, that's obverse. And some non-P is not non-S. Contrapositive. All right, now, besides the fact that I lost you on all of that, and you're going to have to watch it 10 times before you can understand what I'm saying here. What the point of all this is to show you we have all these different statements, but then we have negatives, we have a variety of ways of saying them. In logic, we try to take statements, break them down so that we understand the way that they're working, so we understand what statements do and what they can do, and what is being said in a statement. In our 8th grade logic class in our school, we study these things so that students can put them into syllogisms. Every kind of argument can fit into a syllogism, and then they can examine the validity of that syllogism. I'm showing it to you here in rhetoric so that you understand the theory behind these things. So, that's everything that we need to say about the statement. Next, we want to talk about arguments. Now, an argument is a set of statements, one of which appears to be or seems to be implied by the others. So when we talk about arguments, we're not talking about what you do with your roommates or other girls in the dorm or your sisters at home. We're talking about a set of premises that imply a conclusion or lead to a conclusion. Again, an argument, a set of statements, one of which appears to be implied by the others. It is the verbal expression of inference. When we're looking at arguments, we need to learn to identify the conclusions and the premises. And so there are some key words that we can call premise identifiers and keywords that we call conclusion identifiers. The premise identifier as opposed to the conclusion identifier. The premise identifier, when you see these words in any kind of argument, whether it's in a formal setting like a syllogism or just in everyday conversation, understand that someone is making a logical argument. It may be inductive, it may be deductive. But it is a logical argument, and you need to learn to listen for it. Words like because, since, for, based on the following facts. This is a premise. These are premise identifiers. Conclusion identifiers are usually easier to identify. Conclusion identifiers would include thus, therefore, so, etc. In conclusion, and other terms that you would guess. When you see a premise identifier, what comes after a premise identifier is, you guessed it, a premise. But what comes before a premise identifier is the conclusion. The conclusion comes before the premise identifier if the premise identifier is in the beginning of the sentence or argument, or at the end of the argument. So, for example, we might say, you can't go to the store because you didn't clean your room. The premise is, you didn't clean your room. The conclusion is, you can't go to the store. So, understand that. With conclusion identifiers, wherever they are in an argument, the conclusion is what follows. So if they're in the middle, you can assume the premises are before it. But that's not necessarily always the case. There are 3 types of arguments we've identified already. They are inductive arguments, syllogisms, and enthymemes. An inductive argument uses examples, analogies, comparisons, and so on. All right, here are some examples. When the phone rang during dinner, it's usually been a salesman. The phone is ringing, it's dinner time, I'm guessing it's a salesman. All right, that's an inductive argument. Here's another example of an inductive argument using examples. Most people who test positive for HIV have contracted AIDS. Greg tested positive for HIV, he will contract AIDS. All right, so there are ways of strengthening inductive arguments we've spoken about before, so I'll move through this swiftly. More examples strengthen an inductive argument. More similarities between examples and conclusions. For instance, if you say, let's see, the last time I walked out the side door of the church, something really terrible happened. I'm not walking out the side door of the church again. Well, that kind of thing gets a little silly and superstitious. And rightly so, we consider that to be superstitious. On the other hand, if you say, the last time I walked out in the traffic, I got hit by a car, I'm not walking out in traffic again, the example is much more closely related. You can see the relationship between that and the conclusion. That strengthens the inductive argument. When the similarities are not affected by the many dissimilarities in the examples, again, my example of going out the side door of the church, I'm only going out the front door from now on. The last time I wore this sweater, he wouldn't look at me all day. All right, that kind of thing. Hi. That kind of thing is, again, a little bit superstitious in that way. Another way to strengthen inductive argument is to use points of difference between to minimize the points of difference between the examples and the conclusion. And the other is to make sure that the conclusion is not too strong relative to the example. So you don't want to argue, for instance, that he's got a fever and spots in the back of his throat, he probably has cancer. He has a fever and spots in the back of his throat, he's really sick, he must have cancer. Okay? That's a little extreme for the conclusion. We could back off the conclusion a little bit and be much better. All right, so can we prove that the sun will rise in the east tomorrow? Well, we can't prove it deductively. There isn't a valid deductive argument that will prove that the sun will rise in the east tomorrow. But there is a strong inductive argument that is going to rely on past fact. All the days that have passed. All the days in the history of the world. All the days in my experience. All the days in my parents' experience. All the days in recorded history, and so far as we know, all the days in the history of the world, the sun has risen in the east, and therefore we say that it's safe to assume that the sun will rise in the east again tomorrow. All right? How about, let's see, could we argue inductively that one of the students in this class will become a teacher? Well, we would consider the number of, first of all, the number of students, graduates of Fairhaven Baptist College who have become teachers. And factored into that, the number of students in this class who are pursuing a teaching degree. And we can factor in also the chance, the number of students pursuing a teaching degree who actually become teachers. We can factor all those things in, and we can get a strong deductive conclusion. Okay, could we argue inductively that there is life on other planets? Yes, absolutely, we could. We could argue it. Would it be a strong argument or a weak argument? Well, you can have fun with that one. All right? I think we'll stop right there.